So we're going to review the integers real quick before we talk about the rational numbers. So the integers, if you will recall, is this set of numbers. It's the natural numbers, the negative natural numbers, and then 0. Or you could say it's the positive and negative whole numbers if you want to think of it that way. No decimals or fractions though. We don't see decimals and fractions until we get to the rational numbers, and inside the word rational numbers is the word ratio. So these are numbers that can be expressed as the quotient or a ratio, a fraction, of two integers, a and b. So pick any two numbers from this integer set and you can put one over the other as long as b is not 0. And you'll have yourself the set of rational numbers. So it's made up of integers. A, the top of the fraction, is called the numerator. B, the bottom of the fraction, is called the denominator. Definitely need to know those words. And to understand the meaning of a fraction, when you write A divided by B, that's what this little fraction bar means, divided by. You have to consider the whole. Usually the whole is 1, whatever represents 1 in that particular case. The number of B-sized equal parts that the whole is divided into. So whatever the denominator is, that's how many pieces you're going to be cutting the whole into. And then the number of parts you're considering would be the numerator, right, this A. How are you considering one of the pieces or two of the pieces or three of the pieces? How many of the parts are you considering? So we're going to start by just dividing some shapes into some fraction parts. So this says divide each rectangle into 4 equal pieces. And the reason I have more than one drawing is because there's more than one way to do this. So one way you can draw a rectangle into 4 equal pieces is you cut it in half vertically and then you cut it in half horizontally. And this would divide your shape into fourths. If we have 4 equal pieces, those would be fourths. Right, so each one of these little pieces would be considered 1/4, and all 4/4 equal 1. Another way you can divide it is you can just do it vertically. Pretend these are all straight lines and it looks awesome, okay? Just go with me here. So those would all be fourths, all those pieces are the same size. Or you can cut it in half, and then each half in half, again, horizontally, and those would all be equal to 1/4. I think generally these first two pictures are more than likely what you would see. Then if we want to divide a shape into 3 equal pieces, if you have a triangle or a circle, you have to kind of think about the center of the shape. So like with a triangle, if we start with kind of the center, you can either draw lines out to each corner, and that will divide the shape into thirds. See, it divides it into like 3 little triangles. So these would be thirds because we're cutting it into 3 pieces. And I went to each corner. Or what you can do is from the center, you can go to the center of each side. And that kind of creates like little kite-shaped pieces, and those would also be thirds. And in a circle, you again find the center of the circle. I usually draw a line to the top, and then it's, you know, kind of like a peace sign a little bit. That's one way that you could cut it into thirds. You can't use like vertical or horizontal lines when you have triangles and circles. That only works if you have rectangles. So this is how you would split one of these shapes into thirds. So now what we're going to do is some examples of, again, drawing some fractions. So this says if the following rectangle represents 1, so this rectangle, they're telling us it's equal to 1. Draw a rectangle that would represent 3/4. So you always want to look at the denominator first because that's kind of like the language or the fraction family that you're dealing with. So this is going to be fourths because the denominator is fourths. So we're going to cut the shape into fourths. So we're going to cut it into 4 equal pieces. And we want to draw a rectangle. We're not going to be shading. We're going to draw a rectangle that represents 3 of those fourths. So I'm going to cut it in half vertically. Again, pretend that was a nice straight line. And then I'm going to cut each of those halves, or each of those, halves in half, and that would give me fourths. So each one of these would be considered 1/4. And all 4/4 would equal the 1. So if I want to draw a rectangle that's going to just represent 3/4, then my rectangle that I'm going to draw is going to be shorter than the original rectangle, and it's just going to be 3/4 long. And so that would be the rectangle that I would draw that would represent 3/4. And you don't have to do this part, but if you wanted to kind of cut it, you can see it's 3, and each one of those little rectangles is worth 1/4. So that's what it would look like if it was 3/4. So let's do some similar problems to those. If the following rectangle represents 2, shade the area equivalent to 1/2. Okay, so they're telling us that this is equal to 2. So really, to work with fractions, you need to know what 1 looks like. So if I were to cut this rectangle in half, each one of these would be equal to 1, right? The 2 1s would equal a 2. But I want to shade an area equivalent to a half, not a half of the shape given, but a literal 1/2. So I'm going to have to cut 1 into halves, because this is my language. It's half language, or my fraction family is halves. So I have to take each one and cut it in half. So when I cut this one in half, and when I cut this whole in half, now each one of these long rectangles is equal to a half. And these 2 halves make a whole. And then these 2 halves make the other whole, and so that's worth 2. And it says shade the area equivalent to 1/2. So I'm just going to pick one of these to shade. And there I've shaded an area equivalent to a half. This one's a little tricky though, because the original shape is not worth 1, it's worth 2. So those are the things you kind of have to consider when you're doing these shapes. Now the following rectangle represents 2/3. Draw a rectangle that would represent 1. So 2/3. How many? 2. What are they? They're thirds. So see how the denominator is a 3, so that's the language. So we're not going to, this is not equal to 1, so we're not going to cut it into thirds. This rectangle is equal to 2/3. So if I just knew what 1/3 looked like, I could stack a third, a third, and a third, and that would be 3/3, and I would have 1. Because in thirds language, 1 is equal to 3/3. Y'all know that that cancels and gives you a 1, right? Because 3 divided by 3 is 1. So this is 2 of them. So if I cut this into 2 pieces, each piece is a third. So this would be a third, and this would be worth a third, and there's my 2/3. So I'm going to draw a rectangle that would represent 1. So my rectangle is going to be longer than this one, because 2/3 is smaller than 1. So how big is my rectangle going to be? Well, it's a third, and then another third, and then I'm going to kind of eyeball another third. And that would equal 1. See how it's got a third, and then another third. That's my 3/3. How about this one? The following circle has a value of 3 halves. Okay, 3 halves. That's what this says, right? 3 halves. So there's 3 halves sitting in this picture. There's 3 of something, and the somethings are halves. In halves language, because our denominator is 2, what would 1 be equal to? Well, 1 would equal 2 halves. So this picture is 3 halves, kind of like the last picture was 2/3, so I cut it into 2 pieces. I'm going to cut my circle into 3 halves. So we did a picture with thirds on the last page. So this is 1/2 and 1/2 and 1/2, and you can see that this picture contains 3 halves. But what I want to do is shade the area equivalent to 1. So I'm going to pick any 2 of these halves, whichever 2 you like, and you're going to shade 2 of them. And that shape would be equivalent to 1 because it's 2 halves. So you really do, on these problems, need to consider what is the numerator and what is the denominator, because the numerator and the denominator tell you different pieces of information.